Hello everyone. In this video I'm going to be talking through what transistors actually are and a little bit of information about how they work. So transistors ultimately, they're like the building blocks, if you like, of electrical components. The first devices that really made any use of these transistors were radios because they can be used to amplify a signal. But the computers that we have nowadays contain a vast number of them. Ultimately, a transistor is a component that allows a small current, so a small amount of current, to control a larger current, essentially. Allows the flow of a larger current by ultimately controlling a smaller one. So it's used almost a bit like a relay in that it's an electronic switch. So transistors, we'll just make a note, so transistors ultimately are or is like an electronic switch. That's the best way to think of them. So transistors are like electronic switches, and they use a small amount of current to control the flow of a larger one. So we'll just make a note of that as well. So use a small current to control the flow of a larger current. So let's think how they work and what they look like. So we're going to draw the circuit symbol. Now I do have a separate video on circuit symbols used in physics, so I think it refers to this one, but we're going to draw out the circuit symbol for a transistor, and it looks a little bit like this. So we have a circle, a line just here, one that comes in, comes up and out down here, and down, and this one with an arrow. Now, so there we have the circuit symbol. So I'll just make a note of that. So this is the circuit symbol for the thermistor, but we can put some labels onto this particular image. If we put a B over here, a C over here, and I'll explain each one in turn, and an E, it will help us to describe exactly what a thermistor comprises of and how it works. So, as I said, a thermistor acts like an electronic switch. They can be much smaller than mechanical switches, and because of that fact, you tend to get them integrated into circuits. An example of that is in the use of logic gates, and logic gates I have a separate video for. So let's talk about the three parts that we've labelled here in this transistor. In fact, just to add on a sort of side note, there are many different types of transistor out there, but the one that exam boards tend to refer to is what's known as the NPN transistor. So this is an NPN transistor that I'm referring to here. So I'll just put that in. So there's three components to this transistor. First of all, the B. Let's explain what the B is. The B represents the base. Now that ultimately is the switch, if you like, that controls the flow of current. So when a small current is applied to the base, a large current can flow through what's called the collector and the emitter, the C and the E. If no current is applied to the base, then it stops current flowing through the rest of the transistor completely. So this is our base. It's a switch that controls the flow. So I'll make a note of that. It's a switch that controls the flow of current. And as I said, you need a current being applied to that base to allow a larger current to flow through the rest of the transistor. So let's talk about C in this diagram. So the C here represents what's known as the collector. So we'll put that in place, the collector. Now current flows into the transistor through the collector. So we'll just make a note by just writing current flows in. That's the key thing. So the current flows in through the collector, and you might guess that current flows out of the transistor through the emitter. So the current flows into the transistor through the collector, and the current flows out of the transistor through the emitter, and that's what the E is that we have here. So E is the emitter, and this allows current to flow out. So we've got the base, the switch that controls the flow of current. Current can flow into the transistor through the collector, and if we have a small current applied to that base, then it allows the large current to flow through that collector and ultimately out of the emitter. So we've got three components to this transistor. So you can see it acts like a switch. We need a current applied to this base to allow the flow of a large current through this entire component. And there is a formula, a physics formula, that links all three three components I'm talking about, the B, the C and the E. But we can put values to these, and it's this particular formula. I with a small e is equal to IB plus IC. And let's explain what these refer to. So I in this refers to current. The letter for I here, that refers to current. That's why we use that symbol. E refers to current in the emitter. So we'll just put a little purple circle to represent that one. The B, as you might guess, refers to the current in the base. And the current that flows into the transistor through the collector is C. So let's just give an example. So let's say we've got a current of 0.5 amps applied to the base. So in an example, we've got a 0.5 amp current at the base of the transistor, and it's allowing a current of, let's say, 3 amps to flow through the collector. So that allows 3 amps through the collector. And the question you may be asked is to work out the current that flows through the emitter. So the current through the base plus the current through the collector would equal the current through the emitter. So that would simply be, let's do the maths, 0.5 plus 3. So our value therefore would be 3.5 amps. So that would be the total out through the emitter. So the total current would be, in this example, 3.5 amps out of the emitter. Hence why I've done it in a purple colour. So there we have just a little information about transistors, what they are, how they work. So they're little electronic switches, and we use ultimately a small current to control the flow of a larger one. Got 3 components, a base, a collector and emitter, and through a little handy formula that I've given at the bottom of the video just here, we're able to calculate the current that flows through that transistor. Okay, hope all that helps.